Okay, now that you've learned about the three types of linear forms, which, as a reminder, first is point slope form, which is in the form of y minus y1 is equal to m times x minus x1. There's slope intercept form, which is equal to y equals mx plus b. And there's standard form, which is ax plus by is equal to c. So now that you have those three forms, we're going to practice converting between linear forms. Now, if you notice, in slope-intercept form, we have y on this side by itself on the left side of the equal sign. So that means anytime you're putting anything in slope-intercept form, you are solving for y. We also have standard form, which has c. C is the constant by itself. So anytime you're putting anything in standard form, you are solving for the constant. Now I'm going to add a caveat to standard form. Standard form, when you solve for it or put something into that form, you need to have x not be negative. You do not want a negative x. I can tell you from personal experience, having a negative x is not fun. That's probably why he became my x, because he was too negative. And all the numbers are integers. When they're integers, that means that they are not decimals, they are not fractions. So if they are, you need to get rid of that. And they do not share a common factor other than 1. That means that just like you reduce fractions, you need to reduce standard form. And I'll show you a couple examples of reducing standard form before we move on to converting between linear forms. So here we have something in standard form, which is ax plus by equals c. In this case, we have 4x plus 2y equals 10. And if we look at this, we can see that 4, 2, and 10, all of these here, are all divisible by 2. So because we need them to not have a common, just here, they cannot share a common factor other than 1. They share a factor of 2. So we're going to divide everything by 2. So in this case, if we have 4x divided by 2, we're going to get 2x. We have 2y divided by 2, so that's just going to get us y. And then times divided by 2, which is going to get us 5. So anytime you write standard form, you need to get the most reduced form of standard form. So this would be the correct answer. Now in this case, we have another thing that's standard form, ax plus by equals c. But we have 3/4 x plus 3y is equal to 2/7. Now, because, just reminder in the notes, that we need all numbers to be integers, that means that no numbers can be fractions or decimals, and we have fractions in here. So we have to get rid of these fractions. The first thing I see here is that we have this 3/4 x. So we want to get rid of that. So in order to get rid of that, that means we're going to do this huge distributive, and we need to multiply everything by 4. By multiplying everything by 4, that gets rid of this 4 in the denominator here. But what we do to one thing, we're going to have to do to absolutely everything. So we have 3/4 times 4, which is going to get us 3x. And then we have 3 times 4, which is going to get us 12y. And then here we have 2/7 times 4, so we're going to end up with 4 times 2, which is 8/7. Now, that did some stuff for us. However, it did not get rid of absolutely everything that we need to get rid of, because we still have a number that's a fraction. We have this 8/7 as our constant. So we need to get rid of that as well. So we're going to, again, do this large distributive property. We're going to multiply everything by 7. By multiplying everything by 7, we're getting this 7 out of the denominator, which means that we get this 8 here. But because we do that, we need, with this one number, we need to do that with all of the numbers. So we're going to make this 7 times 3x here. So we get 21x. And then we need to do 7 times this 12y, and 7 times 12 is 84, so we get 84y, and I already brought down this 8. So in this case, 3/4 x plus 3y is equal to 2/7. As a proper standard form is going to be 21x plus 8y is equal to 8. All right, so now that we've done that, and hopefully you get a general idea of how to reduce standard form, we're going to start practicing going from standard to slope-intercept form. So just a reminder that slope-intercept form is y equals mx plus b. And so that means that we're going to be solving for y. So when we look here, we're trying to solve for y. So we're going to use our SADMAP, just like we did for any other variable. So first thing we're going to look for is any subtraction or addition. I see that this here is happening to the y. So let's get rid of this 4x on this side. We need to subtract 4x from both sides. And if we do that, these cancel out here. So we get 2y is equal to 6 minus 4x. Now, we need to get this y alone. So we see that there's a 2 next to the y, which means that 2 has been multiplied by y. So we need to do the opposite of that, which is divide by 2. So that gets rid of that here. What we do on one side, we have to do on the other side. So that means we're going to have to divide everything here by 2 as well. So when I do this, that means that this could also be written as when I put 2 in the denominator like that, or divide everything by 2. That means it's the exact same as 6 over 2, or 6 divided by 2, minus 4x divided by 2. These two things are the same thing. So we have 6 divided by 2, which is going to get us 3. So we're going to have y is equal to 3. And then we have minus, and we have our 4 divided by 2, and that's going to get us 2x. Now, if we want to put this in proper slope-intercept form, which is y is equal to mx plus b, then we could just switch where our mx and b are. So we're going to have y is equal to, because this is minus 2x, it's going to be a negative 2x. And because this is a positive 3, it's going to be plus 3. So we just converted this from standard to slope-intercept form. Now we're going to practice going from slope-intercept to standard with the same equation. So right here we have, I lied to you. We're not. We'll do that this time. But we have standard to slope-intercept. So in this case, we have negative 7x minus 8y is equal to 8. So we're going to solve for y because we're trying to get y equals mx plus b. So we want to see what has been done to this y. First thing we see that there's this negative 7x. So in order to get rid of a negative 7x, we need to do the opposite of that, which is going to be a positive 7x. We're going to add 7x to both sides. So when we have a negative 7x plus 7x, that gets rid of those there. And then we have 8 plus 7x. And those are not like terms, they can't combine. So we have negative 8y is equal to 8 plus 7x. And the next thing we need to do is look and get rid of this negative 8. We have a negative 8 by the y, which means that we are multiplying, so we need to do the opposite of that, which is going to be divide by negative 8. And what we do on one side, we need to do on the other side, so we're going to divide by negative 8 here. Just a reminder that when we have both of these in the numerator and negative 8 in the denominator, it is the exact same thing as having 8 divided by negative 8 plus 7 times x divided by negative 8. So however you want to write it, both are right and they're both the same. So here we have y is equal to, because we have this, those cancel out, 8 divided by negative 8, which is going to be negative 1. And 7 divided by negative 8, which we can't reduce, so we're going to have 7/8 x. If we want to write this in y equals mx plus b, we're going to have to flip the negative 1 and the negative 7/8 x, because right now we have y is equal to b minus mx. So we have y is equal to, because it's minus 7/8 x, it's going to be negative 7/8 x. So our slope here would be negative 7/8. And then because it's a negative 1, it's going to be minus 1, which means our y-intercept is going to be a negative 1. Now we're actually going to do from standard to slope-intercept, we're going to go back from slope-intercept to standard. So just a reminder that standard is ax plus by is equal to c, where c is the constant, which means a number that does not have a variable attached to it. We want to solve for the constant. So our constant here is this, so we want to get that all alone. So I say that we have this y is equal to 7/8 x. So what we want to do is we want to subtract this 7/8 x from both sides in order to try to get that constant alone. So now we have, I didn't put that 7/8 x there. So now we have y minus 7/8 x is equal to negative 1, because these here canceled out. And if we want to rewrite this with the x first, because we ax plus by equals c, we'd have negative 7/8 x plus y, because it's positive y, is equal to negative 1. The problem here is we have a fraction as 8, and all numbers need to be integers. So we're going to need to get rid of this fraction. We're going to get rid of this fraction. We're going to multiply everything by the denominator, which means doing a mega distributive. We're going to multiply everything by 8. In this case, we have this here, which gets rid of the 8 here. So we have negative 7x. And then we have 8 times y. So we're going to get 8y. And then we have 8 times negative 1. So we're going to get negative 8. So when we convert it back, we now have negative 7x plus 8y is equal to negative 8. And we have an issue here because we cannot have a negative x. So what we're going to do is we're going to multiply everything by negative 1. And the reason we're doing that is get rid of this negative x, but to keep everything the same. So we're going to get 7x minus 8y is equal to 8. So there you have it. We went from the slope intercept back to standard form, and we had to do a lot of some moving there, but that's how that works.